This screencast will cover information or a solution for the interaction diagram practice. And we'll start with the simplest one. First one is draw a picture, interaction diagram, and force diagram for the phone on the left. And we have some additional information. Each iPhone is at rest and weighs 11.5 newtons. Draw a force diagram for the phone on the left. And remember that weigh and force of gravity are the same thing. Okay. We're going through our problem solving step. What are we looking for? Okay. So I'm trying to find or make an interaction diagram. I'm given that the phone weighs 11.5 newtons. Another way of saying that's force of gravity, and they're at rest, so I know the net forces are equal to 0. An important relationship or formula is that the net force is going to be equal to the sum of forces. Okay. For the solution, I'll go through, and that'll be up in the drawing before. I want to create the interaction diagram and then the force diagram. Okay. So I'm going to make the force diagram for this object on the left. There we go. Again, the one other thing I'm going to add to this I like to do is go ahead and put the Earth in here. Okay, so if I go through and I have my non-contact forces, and we're really only talking about gravity in this case. Okay, between the between the iPhone and the Earth, I've got a force of gravity. Okay, and between the table and the Earth, I've got a force of gravity. I think pretty much that takes care of the non-contact forces. Our contact forces, we'll start with normal. That's the force that keeps objects from passing through each other. I've got a normal force between the phone and the table. And I also have one between the table and the Earth, or else the table would sink into the ground. Let's go ahead and make the force diagram. Remember, I'll enclose my object, which is going to be the phone. And then for each line that passes through my enclosure, I need to have a force. First one we'll take a look at right here. I've got that force of gravity. So here's my dot. My phone becomes just a single dot. I've got a force due to gravity. Okay. And I come around here and I have a normal force between the table and the phone. I know that the table is pushing up on the phone, and that's a normal force. Sorry for the poor penmanship. The other thing is I know that my force of gravity that was given to me is 11.5 newtons. Okay. Now if we come down here, we know our relationship or formula is that the net forces are equal to the sum of forces, and we're given that the net force is equal to 0. And in other words, our object is balanced. If I have 11.5 newtons down, I must have 11.5 newtons up. Okay. And I've got my solution. I have my interaction diagram, and I have my force diagram. Let's take a look at that last part. Okay. Explain what your solution means in a sentence, and is your answer reasonable? Or in other words, the smell test. Let's see, is it reasonable? And we'll add that in there in just a moment. That I have a weight of 11.5 newtons. Yep, it says that it weighs 11.5 newtons, and I have 11.5 newtons pushing up on it. Same as if I was standing on a scale. That scale measures the normal force. So to put that in a couple of sentences, we have here the Earth, or gravity, pulls down on the phone with a force of 11.5 newtons, its weight. The table pushes up on the phone with a force of 11.5 newtons, and the forces are balanced. Yes, this is reasonable.